Hello everyone, welcome back to MGF 1131. So last week we talked about simple interest and compound interest, and we know that if we compare between those two, we know that compound interest is it making more money, more interest than the simple one. Now, in this video, in this new section 8.5, we will talk about one of the application of compound interest. Um, we're going to be discussing a concept we call the annuity. Okay, then we're going to see how we come up with the formula to calculate accumulated amount in annuity. So, what is annuity? So let's get started. Section 8.5. Section 8.5. That's what I believe. So let me go ahead and check it one more time. No, not this one. I just want to check. I'm sorry. Where is that? Okay. Let me check the schedule again. Let's see where we'll be at. uh, I think it's 8.5, but I want to make sure. Where is that? Right here. Yeah, 8.5. So 8.5 is also about other method of serving an investment, but we're not gonna cover that. For example, the other investment is stock and bonds, and we're not doing any calculation on that. So we'll just focus on annuity. Okay, just focus on that part. So annuity, new. Uh, So what is annuity? So annuity is type of investment, and it based on a compound interest. This look like the IRA things, some kind of investment, the retirement one. So let's just think about it. You pay every month uh, a certain amount of money, and by the time you retire, it's going to accumulate it, okay, and you have a pretty large money, okay. It's, of course, it's much better than you put money in the bank. So kind of similar to insurance, but I'm not really sure what kind of formula, what kind of math behind insurance thing, because insurance they have many planes, but it kind of same thing as insurance, but the only difference in insurance is that you died, and your family member is gonna receive the benefit. But annuity is like it's you receiving the benefit after you retire. Okay. So in the first example, so and again, annuity is just a type of investment. So in the first example, we're gonna go straight to example to see how we derive the formula. Then, since after we got the formula, we're gonna use the formula directly to calculate the accumulated amount in annuity. So I'm gonna go straight to the first example here. Example number. So let's read the problem here. You deposit $1,000 into a saving plan at the end of each year for 3 years. Historical rate of return is equivalent to 8% compound annually. So you see that over here, say compound annually. So we know what kind of formula we have to use already. Find the value of annuity after 3 years. So we're gonna do step by step in the first example. We're not gonna go get the formula. At this moment, you don't know the formula. So we're gonna use what we learned last time to calculate the cumulative amount in annuity. Okay. So answer. So we know the compound interest annually. The formula will be A equal P1 plus R. N is because annually, so n equal 1 raised to the nt, so n equal 1, so n 1 times t is just raised to the t. So we're going to use this formula here, but this formula is just regular compound interest annually we learned last time. Now we know that we have $1,000, so we just go ahead and the first year is 1,000 because you have to deposit $1,000 into the investment on the first year. Then on the second year, we can calculate it by based on the $1,000 you put it in, and with the interest 108 raised to the second year, so t after the first year, so t equal is the first year, so the second year will be t equal 1. Okay. Then of course you need to add up the first year also, so we're gonna have something like this. So we're gonna end up with $1,000 times 1.08 plus $1,000. Now we're gonna go ahead and put into the calculator. Let's see what it gives you. So okay, so we have 1,000 times 1.08, and of course you have to put 1,000 also. So after the second year, you're gonna have $2,080. Okay. Now how about the third year? Because it asks you to find the value after 3 years. So the third year, of course we're gonna give the same thing. Of course we're gonna use this new one. This is the new value we have to compound. 2080 1 plus R raised to the 1t after only 1 year, so 1. And don't forget that you have to pay premium on the third year too, so you gotta add up one more $1,000. Right? You see that every month we have to pay premium $1,000 every year. Okay, you see that it look like the retirement plan, right? See, also they're gonna give you 1.08 plus $1,000. It is give you 20801 times 1.08. Okay, plus 1,000 give you $3,246.40. Okay, so after 3 years, that's what you have. Now, for question B, they ask you the earning on the earning on the investment. So we have to calculate the earning. We know that every month, every year we have $1,000. So it look like we pay $3,000. So the earning is about 3246.40. You minus $3,000. Put into the calculator, which is give you $246 and 40 cents. Okay. Again, the reason you have 3,000 because each year we have to pay off your pocket 3,000. We gotta put in that investment. Okay. All right. Now, so if you notice, you see that every year we gotta have this part, right? So you have like 1 plus R. We have 1 plus R. So see the part over here. The reason you have over here 2.08 because of this one, right? So look like that you have P times 1 plus R raised to the second, right? Is that? So it's gonna be in this form. If you notice from here, you're gonna derive the general formula is like P A equal P, then plus P1 plus R, and plus third year will be P1 plus R squared. So after many years, you're gonna have something like this, right? We one after n year, so we're gonna have P plus R raised to the T minus 1, right? The T, the number of year. Okay, so that's after T. Okay, so you have to do subtract. So based on this one is come from the formula. Okay, this one is it generates from this, basically generate from this. Now from here, from the A here, we can get the formula is A equal P 1 plus R raised to the T is the number of year after T year. Okay, after T year, minus 1 and over R. Okay, so based on this, I have this. Based on this, I have this. There you go. So I'm gonna go ahead and box it. Okay. So this is a formula accumulated amount after T years with the rate. Okay. Okay. Of course, this is include every premium you have to pay. Okay. Now, so after we derive the formula, we're gonna on the second example, we're gonna use the formula to calculate the annuity, because we cannot do like this manually step by step like this as the one we did in example 1, because these are the 3 years. So think about the annuities for like 40 years, 30 years. So think about it, we're gonna have to do one by one like this. It's gonna take a lot of time, so that's why we gotta use the formula. So on the example number 2, I'm gonna go ahead and type the whole example with you. Let me see. Okay, I'm gonna go ahead and type the whole example with you. So I have an example like this: to save for retirement, you decide to deposit 1,000 into IRA. Oh, I'm gonna see if I can make it bigger. Into IRA at the end of each year. Okay, for the next 10 years. You know, IRA is kind of retirement plan. Okay, if you can count on an interest rate, you know, if you don't understand IRA, you can go ahead and ask your parents and ask them if they have IRA or not. Actually, to me as a professor, I have to be honest with you, I don't know if I have IRA or not. I don't think I have IRA, you know, but I have some kind of retirement plan. They come from the school, but to be honest with you, I don't understand. I know I don't know how to calculate it, that part. Most of the retirement plan is calculated by the computer, you know. So I don't know. I have annuity or some kind of other, but in order to for you, you can go ahead and ask your parent if they have how it goes, how to calculate it. Believe me, I'm sure that your parents probably they don't know either, because they probably put in some kind of investment for retirement, but they don't understand how the math behind. Okay, to me, I understand the math behind, but I don't know which one I have, because there's so many different type of retirement plan. 10% per year. Okay, compound. So over here is still compounded annually. Okay, annually. Okay. Part A. and I want to calculate how much will you have from IRA after 30 years. And part B, find the interest. So you see the problem is similar to example 1, but the only difference is that for this time we're gonna use formula. Okay. Okay, I need to put it in white color. Let's see how I'm going to put it in the white color. How am I going to put it in the white color? Uh-oh. I don't know how. No, let's see. I'm gonna go ahead and fix it later because I tried to put it in a white color, but it looked like it doesn't work. Uh-oh. I don't like this one. What is that? Oh, right here, text color right here. Okay, I try to delete this. There you go. Okay, right here. Got it. Uh-oh. There you go. Alright, so let's do the problem together. Alright, so we're gonna go ahead and use the formula directly. Answer. So we got a formula up here. So all you have to do is just plug it in. A equal. Okay, P. P is $1,000. Okay, $1,000. 1 plus R is 1 raised to T. T in this case 30 year minus 1 over 1. Okay, you're gonna put the whole thing into your calculator, okay? Let me go ahead and calculate a little bit first. 1 raised to the 30 minus 1 over 1. You gotta use a graphing calculator, put the whole thing in, and you're gonna have 494. What is it? So you have $164,000 and $494. So you see that after 30 years and every year, think about it. If every year you put $1,000 in, so after 30 years you have only 30,000, right? But because of this is IRA investment with the interest, so after 30 years you have 64. So you have 64,000. You have a lot of money, more money. So you have 134,000 more. Okay, you see that? So if you just leave $30,000 there, it's not gonna make money, right? Think about it. It's no way you're gonna make money with that. So that's why you gotta put in this account for retirement. So you see, 164, 494 minus 30,000. So you see, you much about 134,000 after 30 years. That's a good thing. $134,494. So after 30 years, you make that much. This is very ideal, very good. But they give you 10%. You see that? I don't know what company, what IRS account give you 10%. Probably I don't think they give you 10% though. I don't think so. So 10% is a lot because you see that after 30 you make $134,000. This is a lot of money. For every month you pay only $1,000 every year. So I also have some kind of investment for my kid to go to college, and I have to be honest with you. In order to know how much you make, or for you to be safe, you need to know exactly how it goes. But a lot of investment, I just trust one of my agent, one of my family member. So I don't know how it goes, to be honest. And I don't know that what kind of investment they do. So it's kind of tough though. I have to be honest with you. You have to, in order to do investment, you need to have a lot of knowledge on money. Uh, you know, sometimes you have to trust the people because you don't know. That's why. I may know the math, but I don't know that they whether or not the account for my kid they use this or not. I don't think it's IRA. I don't know. I don't think it's 10%. That's 10% is very okay. So it's very easy. So it's very easy that you can go ahead and then and calculate based on the formula. Now you see that this is the annually compounded formula. It's annually compounded. I'm gonna go ahead and write them over here. Annually compounded. Now what if it's compounded? What is compounded monthly? So then the formula is a little bit different, or daily or something. Then your formula will be something like this: A equals P 1 plus R over N. Remember the compound interest formula? Raised to the NT, that is after the N year, after the T year, minus 1 over that. So N in this case is the number being compounded. So the compound monthly, then N equals 12, daily will be 365, and so on. Quarterly will be 4. And again, I don't think any other investment plan it compound monthly. Okay, it's very ideal. Let me know if you know anything like that. It compound monthly. Let me know. Okay, and I encourage you to do investment in that account too. But I don't know any other account. It's probably out there, but maybe kind of very risky though. Yeah. But let me know if you see something like that. But I have a problem. Same problem, but it's just compiled differently. So I have something example number 3. Okay, I have I have okay. So the problem go like this: at the age 25 to save for retirement, you decide to deposit $200 at the end of each month into an IRA that pay 7.5% compounded monthly. Part A. How much will you have from the IRA when you retire at age 65? So you gotta do subtract right there from 25 to 65 from 65. So 40 year. That's 40-year investment. That's crazy. Find the interest. Okay. Now let's change the color, otherwise you cannot see. There you go. Okay. Okay. Answer. All right. So we know the compound monthly. So we just go ahead and plug them in. So it will be $200. 1 plus 1075 over monthly will be 12. 12 times 40. We go from 25 to 65. So 40 years investment. That's a lot. Minus 1 divided by 1075 over 12. Now again, over here you gotta use calculator. If you don't have calculator, that's a big issue. So 200. So I'm gonna do inside parentheses 1075 divided by 12 plus 1. So over here you're gonna have 1.0065625 12 times 40 480 minus 1 over 1075 divided by 12. You 1.00625. Okay, then you raise to 480. You multiply by 200. Oh, I'm sorry. This is you gotta put the bracket, because you don't put the bracket, everything is wrong. I forgot to put the bracket here. There you go. Okay, otherwise you're gonna have a wrong PEMDAS. Okay, it means that you're gonna calculate inside the bracket first before you multiply by 1000. Same thing over here. You gotta calculate inside the bracket. Okay, then you multiply by the P. Okay, here you go. Then you're gonna end up with around $600, $4,000, $765. Oh, so think about it, $200 per month. Okay, you multiply the by 12. Let's see each year how much you have to pay for premium. Is 2,400. If you multiply by 40 years, so give you around $96,000. So you see, you just have to pay $96,000 in order to get at the end after 40 years, you have 604,765 minus 96,000. Then you make around 604,765, $500,000, 765. So you see that compound monthly, you can make a lot of money. So again, please let me know any company offer you some type of investment that compound monthly. Okay, well actually we don't need to have like 7.5%. If they just give us 5% compound monthly, that is good already. Okay, you're gonna make at least over here $400,000 after 40 years. Which is, think about it, if you put if you save money in the bank, it never will, you never make money that much, right? All right, now we can also get P by, if they give you the A, you can get a P also. So I'm going to offer you the formula. So try to get a P out of A. It's kind of solving the equation we call in algebra, we call the literal equation. So from here, you can have P, you know A already. So you can do A times R over N divided by 1 plus R over N raised to the NT minus 1. There you go. So let's say that the accumulated amount you want $1 million. Okay, you want $1 million. Then how much you have to pay? How much is the premium every month if you want $1 million when you retire? Okay, then you're gonna use this formula here. Okay, all right. Any question? Please let me know. Send me a message to Canvas inbox. Make sure that you gotta get used to the calculation part. Okay? Try to use calculator by yourself. Don't just copy the answer. Use calculator by yourself and see whether or not you get the same number, the same answer. All right. Please send me a message, and I'll be seeing you next time in the next video.